Okay, picture this. The lights flicker. Or maybe you're way out camping, miles from anywhere, and suddenly, poof, no power. Or you're at home, mid-project, and the grid just decides to take an unexpected break. Suddenly, having reliable backup power isn't just nice, it's critical.
Yeah, absolutely. It snaps right into focus, doesn't it?
For ages, the answer was simple, right? The conventional generator. Loud, maybe, but dependable. The undisputed champ.
A workhorse for sure.
But now there's this challenger, the inverter generator. It's getting really popular.
It really is. And it's a sophisticated piece of kit compared to the old style.
So our sources are telling us this isn't just picking a brand. It's a fundamental choice. Really depends on what you need it for.
Exactly. Are you after that rugged reliability, or do you need something a bit smarter, maybe quieter?
That's what we're digging into today.
Yeah.
This deep dive is all about understanding those core differences.
Because that difference in how they make the power, that dictates everything else. Noise, fuel, what you can plug in safely.
All right, let's get straight into it then. Forget the paint job for a second. How did these two machines actually generate electricity differently? What's the core mechanical difference?
Okay, let's start with the conventional one. The sources often call it the brute force method.
Brute force.
Yeah, it's pretty simple mechanically. You've got an engine gas, diesel driving an alternator directly. That spinning action makes AC electricity.
Okay, seems straightforward enough.
But here's the catch. To get the standard 120 volts and 60 hertz we need for our appliances in North America.
Right, the wall socket standard.
Exactly. That engine has to spin at one constant high speed. Usually it's 3,600 revolutions per minute. Always.
Wait, 3,600 RPM nonstop, even if I just plug in, like, my phone charger.
Precisely. Think of it like flooring the gas pedal in your car all the time, even when you're just idling at a red light.
Wow. Okay.
Whether it's one tiny LED bulb or your big power-hungry fridge, that engine is roaring at full speed, burning fuel like there's no tomorrow.
That sounds, well, incredibly inefficient. And rigid. So the inverter generator must tackle this completely differently. Some kind of digital tech involved.
Sort of, yeah. It's a much more advanced three-stage process. Critically, the engine speed doesn't directly dictate the final electricity output frequency.
Okay, walk me through the stages.
Right. Stage one,
Yeah.
the engine runs, and like the conventional one, it generates AC power. But it's often high-frequency AC, kind of rough.
Okay.
Stage two, and this is the really clever bit, that rough AC power gets immediately converted into DC power. Direct current.
Huh. AC to DC. Why do that extra step? Seems counterintuitive if you want AC in the end.
Because that DC acts like a buffer, a clean, stable pool of power. It lets the machine electronically smooth out all the jaggedness and fluctuations coming from the engine running.
Ah, I see. It cleans it up.
Exactly. Once you have clean DC, stage three happens. Sophisticated electronic circuits then invert that smooth DC back into perfect AC power. 120 volts, 60 hertz, pure sine wave.
Pure sine wave. That sounds important.
It is. It means the power is as clean and stable as what you get from the utility grid.
So the electronics handle the quality, not the raw engine speed.
You got it. And because the electronics manage the final output, the engine is freed up. It doesn't need that constant 3,600 RPM.
Ah, so it can slow down.
Precisely. That's where features like eco mode or idle control come in. The engine automatically adjusts its speed based on how much power you're actually drawing.
Okay, give me an example.
Sure. Plug in just a laptop, maybe a small light.
Yeah.
The engine just hums along quietly, really low RPMs. Then, say you plug in a big power tool, like a circular saw.
Yeah.
It instantly senses the demand and ramps up the engine speed to deliver the needed power, then drops back down when you stop.
Wow. Okay. That variable speed sounds like a game changer. Let's dive into comparing them directly. Power quality seems like the biggest difference for modern users, right?
Absolutely. It's often the deciding factor. That conventional generator, with its engine locked at high speed, produces, well, dirty electricity.
Dirty? What does that mean, practically?
It means the voltage isn't perfectly stable. It fluctuates. And, more importantly, it has high total harmonic distortion, or THD.
Harmonic distortion. Sounds technical. Can you break that down?
Imagine clean power as a perfect, smooth musical note, a pure sine wave. Dirty power is like adding a bunch of static hiss and maybe some heavy metal guitar screeches over it. It's choppy, inconsistent.
Got it. Not a smooth note.
Not at all. And your sensitive electronics, they really want that pure note.
And the inverter, with its fancy three-stage process, delivers that.
Exactly. It produces clean power, true pure sine wave power.
Yeah.
Just like grid power. On power quality, the inverter is the clear winner, no contest.
And why should you, the listener, care about clean versus dirty power?
Because dirty power is really bad news for anything with microprocessors or sensitive circuits. Laptops, smartphones, game consoles, modern flat-screen TVs.
Medical equipment, too, I imagine, like CPAP machines.
Definitely. Critical medical devices absolutely need clean power. Dirty power might not instantly fry them, but it stresses the components. It can significantly shorten their lifespan. It's just not worth the risk.
So for anything modern and electronic, inverter is almost a must.
Pretty much, yeah. And tied directly to that variable engine speed are two other huge benefits: noise and fuel efficiency.
Ah, yes, the noise. Conventional generators are famously loud, aren't they?
Notoriously so.
Yeah.
Remember, they're always running full tilt, 3,600 RPM. That typically means noise levels around 75, maybe 80 decibels.
Which is like, what? A vacuum cleaner running right next to you?
Yeah, or a garbage disposal. Constantly. It makes it really unpleasant, sometimes even forbidden, in campgrounds, RV parks, or even quiet neighborhoods with noise rules.
But inverters are different.
Oh, massively different. Because the engine can throttle way down under light load, a good inverter in eco mode might only be putting out 50 to 55 decibels.
That's like a normal conversation or
Yeah.
a quiet dishwasher.
Exactly. It's a night and day difference in usability, especially in shared spaces. Huge quality of life improvement.
And that low RPM must save fuel too, right?
Absolutely. That's the other big win for the inverter. The conventional one is guzzling gas at full speed constantly, even if you're just powering one small thing.
So if I just need to keep, say, my freezer running overnight during an outage, the old generator burns fuel like it's powering my whole house.
Basically, yes. Terribly inefficient for light loads. The inverter, though, just sips fuel when the demand is low because the engine slows right down.
That seems crucial for things like RVing or camping off-grid, boondocking, as they call it.
Essential. Every drop of fuel matters then. The fuel savings over the lifespan of an inverter, especially if you use it often for lighter loads, can be really significant. It adds up.
Okay, let's talk about actually moving these things. Portability. Another area where the inverter seems to have an edge.
Generally, yes. Conventional generators tend to be heavy and bulky for the power they produce. Often open metal frames, need wheels, sometimes takes two people to lift.
Yeah, they can be awkward beasts.
Inverters, because the components are more integrated and often housed in lighter plastic casings, are usually much more compact and lighter for a given wattage.
Designed to be carried, almost.
Yeah, they often have built-in handles, more ergonomic designs. One person can usually handle moving one quite easily. Much better for tossing in an RV or taking to a tailgate.
And there's another unique inverter feature related to power parallel capability. What's that about?
This is a really neat trick. Most conventional generators are what they are. You get the power they're rated for, and that's it.
Right.
But many inverter models are designed so you can link two identical units together using a special cable kit.
And that does what? Doubles the power.
Effectively, yes. It doubles your available continuous wattage. So maybe you buy one smaller, quieter inverter for camping.
Okay.
But then if you have a bigger power need sometimes, maybe during a home outage, you can buy a second identical one, link them up, and suddenly you have twice the power available. Huge flexibility.
That's really clever. Buy what you need now, scale up later if required.
Exactly. A sort of hybrid solution.
Okay, we've sung the inverter's praises quite a bit here. Let's make sure we're balanced. The conventional generator still has its place, right? What are its main advantages?
Absolutely it does. Two big ones. Cost and raw power output, especially starting power.
Right, the price. Inverters sound more expensive. How much more are we talking?
You definitely pay a premium for all that complex electronics and the clean power. In the smaller sizes, maybe 20%, 40% more, sometimes even double the cost per watt compared to a basic conventional model.
So significantly cheaper initially for the conventional.
Yes. If your main goal is getting the most raw wattage for the lowest initial cost, the conventional generator usually wins that comparison hands down.
And the second advantage, durability and power.
Yeah, think about it. The conventional generator is mechanically simpler, fewer complex electronics to fail. The engines are often built tough, designed to run hard.
More robust, maybe easier to fix if something goes wrong.
Generally, yes. Parts might be easier to find, and repairs might not need specialized electronic diagnostics. They're workhorses built for tough environments, like construction sites.
Makes sense.
Plus, for really high-draw appliances, especially things that need a big surge of power to start up like a large well pump or a central air conditioner, the big conventional generators often provide more brute force starting wattage, surge watts, compared to similarly rated inverters.
And they often have bigger fuel tanks, too, longer run times.
Typically, yes. Because they're physically larger units, they often accommodate larger fuel tanks, which naturally translates to longer continuous operation before needing a refill compared to the more compact inverters.
Okay, this gives us a really clear picture of the trade-offs. Let's try and summarize for the listener. When should someone definitely choose a conventional generator?
You go conventional when you need maximum wattage, especially for whole home backup. Think running 240-volt appliances like a central AC, electric water heater, or a well pump. High power demand is key. Also, if budget is your absolute number one concern and you're mainly powering simpler tools or appliances that aren't sensitive to dirty power, maybe on a job site, powering saws, mixers, compressors.
Things that don't have delicate electronics.
Exactly. Or if it's going to be installed permanently somewhere like a shed and noise just isn't a factor, then the cost per watt of the conventional model is hard to beat.
Got it. So conversely, when is paying that extra premium for the inverter the right call?
You choose the inverter whenever powering sensitive electronics is non-negotiable. Computers, home theater systems, medical equipment, you need that clean power, no question.
Right, protecting your expensive gear.
Absolutely. Also, for almost any recreational use, RVing, camping, tailgating, the quiet operation is usually essential. You don't want to be that noisy neighbor.
Definitely not.
And if noise rules are strict where you live or plan to use it, the inverter is likely your only option. Plus, if portability is key, or if fuel efficiency is a major factor, maybe for long off-grid trips, the inverter's variable speed and lighter weight make it the clear winner.
So it really boils down to a trade-off, doesn't it? Clean power, quietness, efficiency, and portability with the inverter.
Versus raw power, lower initial cost, and potentially rugged simplicity with the conventional model.
Understanding that core difference, the fixed speed versus the variable speed, the brute force versus the electronic refinement, that's the key to making the right choice for you.
Precisely. It lets you look past the marketing hype and invest in the generator that truly fits your specific needs and lifestyle.
And here's a final thought to leave you with, drawing from our sources. We talked about the conventional being cheaper up front, right?
Right, lower initial cost per watt.
But consider the total cost of ownership. If you factor in the potentially huge fuel savings from an inverter, especially if used often on light loads,
Good point.
and the potential cost of replacing expensive electronics damaged by the dirty power from a conventional unit, maybe that higher upfront price for the inverter actually ends up being the smarter, more economical investment in the long run. Something to think about.